you need to choose the right tokenizer for a chosen LLM. If you are using API, you will be charged by token counts. Write a Pythonic function. LLM model will have its own dictionary of tokens. What is tokenization? A way to translate into something that the LLM understands. You can come to this website, tick Tokenizer. Alright, so it's time for coding exercise. What if you have two languages? Translate this to English. And non-English, like Thai language, is now split. What if you ask it to describe a function? So basically now you have means to count of how many input tokens and how many output tokens you received. Okay, the second topic is about tokenization. What is tokenization? Tokenization is essentially a way to translating the input text that human can read into something that the LLM understands, which is a series of what we call tokens. Token is represented by a number, right? Maybe a word I is a number 101. Maybe a word cat is 102. And with that number or token number, like 100 or 102, we can convert it to something that the large language model will understand. Essentially, LLM model will have its own dictionary of tokens, right? It can be like a model that is capable, will have a vocabulary as big as 300,000 tokens in its dictionary. Whatever tokens not in that dictionary will be tagged as an unknown. So maybe in the world of the actual world of human languages, we might be able to have 500,000 tokens, but if the vocabulary is only 300 tokens, therefore 200 human language token will be collapsed into just an unknown token for the LLM to understand. Basically, each LLM model will need its own dictionary of tokens, and tokenization is a process of translating human language text into a series of tokens inside that LLM's dictionary. Well, as a concrete example, this is a human readable tokens, right? This is a token for starting the message. This is a system. You are a helpful assistant. N. Start user. Write a Pythonic function called multiply A by B N. So this is a human readable input text. And I just highlight the token when it's been tokenized for you, right? This is one token that the LLM will see. This is another token. So you will see this is the tokens, right? I'm going to show you how this works in a few minutes, but I want to talk about why this is important. There are many tokenization techniques like byte pair encoding or BPE, which is very commonly used these days. It's very high performance, but other techniques exist in natural language processing like word piece or sentence piece. If you are using API, for example, Vertex AI API from Google or OpenAI or Claude 3 API, you will be charged by token counts. So that's the important aspect to know. If you are using tokens by API, you will be charged by token count. Different tokenizers or returns different or will turn the input text differently into different tokens, and therefore different token counts. But the most important thing is, if you are developing your own app or LLM application, you need to choose the right tokenizer for a chosen LLM. An LLM will need to be paired with its matching tokenizer. Otherwise, you will get a gibberish answer because it's like you are using a wrong dictionary for a wrong LLM. And also, you need to keep track of your token users in your app because you are going to get charged by that. So if you are thinking of charging your app user, LLM app users by tokens, you need to count that, right? Let's say if for 1,000 or million tokens, your API provider, for example, OpenAI, for 1 million tokens, you get charged by $10. This is just some made-up number. Then you need to count how many tokens you're using so that you can charge your clients by token count, right? You can quote, okay, to your customers that we are providing a service that for 1 million tokens, it's $15, for example. Okay, now we are going to talk about Token library. But actually, before going to the library, I need to show you how you can play with this tokenization in the website. You can come to this website. Tokenizer.verso.app is a tokenizer that works with OpenAI models. You can pick your models or embedding models here. So you have text search Da Vinci, you have GPT 3.5, GPT 4, the encoders. I'll talk about this later. But you have many models from OpenAI to see. Okay, and you have a chance to construct conversations and count how many tokens will be there and prices as well. But let's take a look at this example. I'm going to go back to my slide to actually put this. I am going to put this in that website. Write a Pythonic function called multiply AB. Write a Pythonic function called multiply AB. This is how it looks like. This is the match message, the human readable message that will be sent into a tokenizer, and this tokenizer is specialized for or is matching to GPT 3.5 Turbo only. By this tokenizer, this whole thing here has 27 tokens in it. This is one token. As you see, you can see it's highlighted. This is another token. This is another token, right? Now, you might think, okay, tokenizer is just splitting a sentence into words. Not necessarily. Look at this. It's splitting Pythonic, it's a word, into two tokens, Python and IC. Now, IC happens many times in English languages or English words, right? And usually it signifies that this thing with an IC at the end will make it an adjective, right? So this is tokenization. You are trying to break word and apparent word into subwords, in which a subword can be applied in generalization. And another interesting thing here is that this multiply underscore A underscore B is supposed to be a name, right? This is a name. But because maybe it's not in the training data set of the tokenizer, it doesn't know this is a name just yet. It's trying to break it down into many components like multiply underscore A and underscore B. Anyway, it's a way to break words into subword. What if I change the model? If I change the model, say to GPT 4, how does it look like? It looks even more difficult to read, right? But again, there are 25 token counts. You see, when I change the tokenizer, the same message, the token count changed. Now, what is happening here? I'm trying to see if I can detect what's changed. But I'm too lazy to do that. What if I pick embedding model? Is there any embedding model here? Right here, text embedding adder 2. Okay, write a Pythonic function. Did I call function? Yeah. Function called multiply AB. Same thing happened with Pythonic, right? It split into Python and IC, and the same thing to multiply. Okay, this is tokenization, meaning you have human readable text. It will be converted into a series of tokens. These are tokens, and each token is represented by an integer or a number. Now, I want to show you Token library by OpenAI. Token library is a fast open source Python tokenizer. It works in Python, but if you want to use it in other languages like C++ or Java, I think there are libraries provided by OpenAI as well. You can Google it, you can search it and look into OpenAI cookbook about token, and you will find more information. As I mentioned, you need to pick the right tokenizer to the right model. There is a way to do that very easily with the Token library. So here, this is a way. If you are going to use a GPT 3.5 Turbo as your LLM, you can say, Token, get me the encoding for this model, and you'll get the right encoding model for your application. It's say fast. In this website, well, it's on its GitHub, it compares itself with the tokenizer from Hugging Face, and you can see the throughput that is so much different. The throughput is on the y-axis. At the maximum, like 16 thread count, it almost reaching 40 megabit per second here. But again, the performance is quite different from the Hugging Face open source tokenization. Now, just to give you a complete overview, encoding schemes is like it's a way to split words into tokens. These are called encoding schemes or encoding names. Different encodings apply to different OpenAI models. They keep improving. Here, CL100K base should be used for GPT-4, 3.5 Turbo, embedding adder, embedding 3, the latest embedding model from OpenAI. So this is the, I guess, it's the latest encoding scheme for Token. GPT-2 is 50K, R52K base, and you also have like P50K base as well. Codex is a model that is very good at giving you coding assistance, is using P50K base. For me, I'm not going to remember what it is. I am going to use this one to give me the right embedding. And this library, Token, is also extendable, meaning that you can use it and you can add new tokens to the library so that you can perhaps train your own or fine-tune your own language models with your own new tokens. As an example here, a new token is merged into the library by using this pattern or syntax. Alright, so it's time for coding exercise to show you actually how TikToken works. Okay, I have everything here. Let me just clear all the outputs, increase the size, connect my collab. Okay, it's connecting to, again, Google's infrastructure. Maybe taking a few seconds to do. The first thing first, make sure that I have OpenAI library and TikToken library installed. So I'm going to run that through. Also, I have my OpenAI API key kept in this tab here, the secret key, and I activate it, or I enable it for this notebook. So yeah, make sure that you have your OpenAI API key and copy and paste in here, and you can load it up using this syntax. So I'm just going to go back to a table of content. So right now I'm running this code to load up the OpenAI API key. I am going to then import TikToken library, and this is one way to get an encoding if you know what encoding scheme you use, or you can use, as I say, get me the right model, get me the right tokenizer. I'm using this model, so I prefer this one. It's easier to make sure that it's right. Okay, now I have my encoder, or the tokenizer if you will, right here. Okay, this is the basic usage. Let's say that I have an input which is in human language, is a Pythonic code. I am going to encode it. Encoding is actually, or tokenizing it is encoding. It's essentially translating human language to a token, right? So I call the tokenizer encode the input for me, and I have this, right? I have a series of tokens represented in integer for me. Now, a tokenizer also has a way to decode, meaning translating the series of text back into human language. You can do that by calling a decode method and input your series of tokens right there. So I get Pythonic code back after decoding it. Now, if you want to decode just one integer, you need to use this function, decode single token byte. It's more reliable to convert an integer to an integer token to a human language subword. And you can see here 3 tokens that I have from the tokenization of a word, of a sentence, Pythonic code. I converted back. I got 3 things: Python, ig, and code. And that's it. You convert an integer back to a human language, but it's in the byte form. Anyway, with this technique, if you have a tokenizer, you tokenize your human language input. You can easily count using this function length. Okay, I am going to show you more example. So I need a function. This function is called process. It will take an input and a tokenizer. It will print what the input is. It will convert the input into a series of tokens. Then it will print how many tokens are there. And then it will print how many, what are those token integers. And then what I'm doing next is I'm converting each token into back into human language, but it's in byte. And then I'm converting a byte into a string in the UTF format. So here it is. I divided my process right here. So I'm going to test with a test and test. Not very creative, am I? Alright, the input is test and test. There are 3 tokens, which are this: 1985, 323, and 1986. Very strange. See? Test and test. I don't need to reason. I think this is an algorithm inside a tokenizer. I don't need to reason. It's different. 1985 and 1296 is different. Could be because there's space over there, but whatever it is, it's there. Alright, next one. My input is Batman man will do anything else, will do a Batman-y thing. I'm interested how it will be tokenized. Here, it has 10 tokens in it. This is a token Batman. Man will do a bat any thing. So yeah, Batman-y. This is not a typical word. It's now the tokenizer is now split it into bat, any. I don't know. It's just the way it does things. What about non-English language? Let's say a Thai language. This word means 2 words. Non-English languages, like Thai language, for example, it will be tokenized by character rather than subwords. For example, here, this is one character, another character, or even a vowel. One vowel is also tokenized into its own thing. What if you have, I keep clicking on it. What if you have 2 languages in an input? Let's say this could be a prompt to ChatGPT or Gemini. Translate this to English. How does it look like? The tokenizer recognizes English, translate as a word, so it's actually put 1 token in it. But then the bracket is 1 token, and non-English language, like Thai language, is now split in character, similar to what we had before, and the rest is typical. So yes, so the tokenizer kind of handles everything inside it. Non-English, English languages, brackets, symbols, it handles everything for you. What about misspelling? Now, I dropped the S, pretending to misspell my input text. The effect is that the tokenizing or the misspelled word might be tokenized differently from the actually correctly spelled word. Like here, translate now is split into tr and late. So tokenizer itself doesn't care or doesn't know that you misspells a word, but the large language model will understand that it will try to correct, or it will try to understand what should be. So if I can show you, I'm sure if you put that sentence into ChatGPT, it will be able to translate it back to 2 words, for example. Hey, what about math? How does it handle? So I have some kind of programmatic word for maths. This is the integrate x squared dx. How does it do it? So it tokenized into int x exponential 2 and dx. Good for me. What about a more difficult syntax? Like maybe this is something to give to a ChatGPT. Find this. The derivative of this thing inside a bracket is an exponential of x squared plus x by dx. How is it going to do? This is what it has tokenized for me. Find is fine. The exponential x by dx, this one token, and dx. Okay, what if you ask it to describe a function? This can be done by ChatGPT for sure, right? Here it is. The input is this one. 18 tokens. You have described the following function. New line. Def symbol print. The name is split into 2. The argument is split even more. And you have that. The rest. So now you have seen a lot of cases that the tokenizer will see in it, in probably your real world application, like misspelling, math, codes, non-English languages, like translations, a combination of English and non-English languages, or even like combination of languages. You've seen many cases now, and the tokenizers will handle everything for you. Okay, the last topic in this section is going to be about counting your tokens when you use OpenAI API call. So let's import the OpenAI, specify my API key, and create a communication client. Here, this is a message that I want to send to the OpenAI system. As a system, you will need to be, you are a helpful assistant. You will assist the user in a polite, helpful, and harmless way. And then a role of a user, that's a message. A message is given to this one, and I will get my response back from the client, and I'll get my response out to this notebook. So yeah, I have defined my get completion code. What is my input again? My input is this. Describe the following function. Essentially, this one. This is my input. So I am basically asking OpenAI GPT to describe this function for me, and I will receive my response very soon. So I have received my response, in which is actually answer me here. I received this one from OpenAI. This function is named simple print, and it takes one parameter, x. It simply prints the value x to the console and then returns none. This is correct. It doesn't perform any complex operations. It just prints the value of x. This is correct. What I don't like is that it doesn't really use good grammar here. How do you concatenate two sentences with a comma? Am I wrong? Anyway, so this is this is the whole response that I get back. The user, when you are building your app, you just want to show this to your client. Oops, I need to, how do I do that? Message. Okay, what am I doing wrong? Oh, choice. Sorry, I need to call choice. OICE, choices. 0, 1, 0, right? Message. Okay, choices. Alright, what is happening to me? chat completion is not so. Okay. Oh. Here. 0 and okay. Well, all right. This is it. If you want to just send a message to your app user, you just need to access this. But if you want to count the prompt, it's right here. It's in usage key, right? And they are actually all these here. So your prompts, essentially this one, it has 49 tokens, and the return count is 51 tokens, and total tokens is 100 tokens. You might want to separate the completions or the response tokens from the input or the prompt tokens, because input prompts and output prompts, they are charged differently. The output prompts are charged more, right? So basically now you have means to keep count of how many input tokens you provide and how many output tokens you received. All right, this is it for tokenization. Again, if you feel this is useful, please subscribe to our channel. If you have any comments or questions, don't forget to put it there in the comment section as well, and I will be happy to answer to your questions. Before we leave this topic, BPE or the byte pair encoding is very, very popular these days, and it has very good performance. If you want to have a deep dive, I recommend going to this website. It has very detailed explanation of this topic. Also, you will be able to see YouTube video from one of the legendary in AI, Andre Kapathi. He will be talking about TikTok and tokenizers, because he works at OpenAI, right? So he actually does a lot of this thing. Thank you very much for watching our video. If you like it, leave a comment. And don't forget to subscribe to our channel, Case Done by AI, and see you at our next video.